Virtual port channel configuration. Before we go to the command line and do later, we will just go through the commands, walk through the commands, understand why those commands need to be typed to get the VPC. So VPC is like 3 devices we need to use to have VPC. The Nexus 5K, let me call it as Nexus 5000. 5K, this is the first device. Nexus 5K2, the second device. These two need to be paired, combined, virtualized. The hardware virtualization. The device need to be combined. We can call it as device virtualization, so that we can have an ether channel between these links. For this, what is needed? First of all, we have to enable the VPC support on this 5000 series. See, Nexus devices supports a lot of features, but not all of them are on. All the features will be there, but they will not be active. In order to activate it, we have to give this command feature VPC. So this is the very first command that enables the feature VPC. Next, I told you we need to combine these two switches as one logical switch, for which we need to provide a domain ID, using which the switch is going to have a common MAC address. We learned that there is a range of MAC address dedicated for this VPC purpose by Cisco. The last 2 bits, hexa bits, will be based on what we configure as a domain ID. The last 2 hexa bit of MAC address will be based on the domain ID that we give. So we combine these two switch with the help of a domain ID. That number should be same on both the switch. Only then they can form a group, form a domain. That's the meaning of domain, now group. So to create the VPC domain, and in order to enter into that VPC domain mode like this, we need to type this command VPC domain. Give any number, but make sure we give the same number on the other switch. Next, domain ID, we understood why we need to identify the group members. Next, we learned that there are 2 links, one called as peer link, which is a layer 2 link, high speed link, and also recommended is a redundant link with ether channel, so that even if one of the link goes down, you will still have this peer link available for us. So we need a high speed layer 2 trunk link. This also need to be a trunk link, and also recommended is a ether channel for a high availability. This we call as peer link, which is for the synchronization between these 2 boxes, because we want these 2 boxes to be considered as one virtual box. A layer 2 trunk ether channel is what going to be a peer link for us. Another thing that I was telling is we need another link called a Keepalive link. And this will be a layer 3 link. Mostly we will use the management interface. The management interface will be member of a VRF called management. We are not going to create this VRF. We are not going to assign this interface to the VRF management. It will be there by default. We can make use of that management interface. When you make use of the management interface for this layer 3 Keepalive link, that VRF will be used. We know about VRF, right? VRF keeps the control plane separate. So this management traffic will not disturb the other traffics. Right, the management VRF. Now, I said it's a layer 3, which needs an IP address. Let us say we got an IP address 10.0.0.1 on this management interface here, 2 on this management interface. So we need to tell the Nexus 5000 series to use this management interface. If I am configuring this on Nexus 5K1, what I'll say is use this management interface IP address as a source IP address that will become 1, and keep sending the Keepalive to the destination. I need to provide the IP address of the next box. You see, on the management interface, if you are configuring management interface as a Keepalive, you don't need to say the source. It will automatically take the IP address of the management interface as a source. But the destination, the peer Keepalive, the peer Keepalive address need to be defined by us here. Likewise, here I'll say my peer Keepalive is 10.0.0.1. Here I said peer Keepalive is 10.0.0.2. And what I'm telling is NK51, you keep pinging this address. Keep pinging. Likewise, NK52, keep pinging 10.0.0.1. Right. Let me show you the configuration related to this. Here we see, when we are inside the vPC domain, the very first thing is we are saying for this domain, peer Keepalive destination, meaning this will be the IP address of the second box. So if I'm in the first box, I should give the IP address of the second box. What is the second box IP address? 10.0.0.2. So if you are using the management interface, this is enough. But if you are using different VRF, different interface, and the interface of the VRF you want to use, then you may need to also specify, instead of peer Keepalive destination, you need to say peer Keepalive destination, the IP address, and the source IP address. And this is extra work. You don't need to do this, but you need to do do this or do this. You don't need to do like this if you are doing under management interface. If you are using the management interface as the peer Keepalive, just this is enough. We don't need to type this big line.
Sir, one question: if you are using management interface, so why we need not to give this VRF?
The reason is by default. When you configure the peer Keepalive destination and the destination IP without giving any VRF, the operating system is designed to use the management interface by default. Only when you are deviating from the plan, we have to mention what plan you got in your mind. My plan is to use VRF my_Keepalive. And then I have mentioned it. Okay, so see, this is not a recommended option, but there is also an option like this in case if you are not happy using the management interface as a peer Keepalive, then you need to create a VRF. Assign any interface from the any line card as the member of the VRF, and then we say peer under the vPC domain. We say peer Keepalive. Destination is 10.0.0.2. But you also need to say the source because you are not using the default source. The default source will be the management source. Because you are not going to use the management source, you need to say, I got another IP address. I got another interface whose IP address is this. Use that interface. That interface will be a member of this VRF. So we have to say this. If we are not using the default management interface. Fine. This is a very important command. We feature vPC, vPC domain, vPC peer Keepalive destination. Next comes the optional one. Configuring the system priority. This system priority is to make the system, the Nexus device, as high or low priority device. We'll talk about that in some time. Next is the role priority. The role priority is like who will be the master and who will be the backup kind of thing. The role priority. We'll talk about these two are optional. We'll talk about this optional thing after some time. Let's finish the important and very important comments. So far what we have seen is only 4 lines of configuration or 3 lines of configuration. Feature vPC, vPC domain ID, and then the peer link, peer Keepalive. Either you use this one with the management interface or use some other VRF and put this command. Next is I was talking about the peer link. The peer link is a layer 2 trunk link, and it is recommended to use a port channel. So the port channel in our picture is PO1, so let me change it as PO1. So this port channel will have 2 or 3 interfaces or 4 interfaces, up to you can have up to 16 interfaces in the bundle. But only 8 will be active. Up to 16 interface in a Nexus device. Up to 16 interfaces you can put in bundle, but only any 8 will be active at a time. The other will be used for the failover. So we go under the port channel, which is in between the 2 switch, and we say this is not a simple port channel. This we are dedicating for vPC as a vPC peer link. And then, as I said, the port channel should be a layer 2 trunk. And I also was telling that we need to allow the VLANs that you want to pass in between these 2 switch. If you have some VLANs that you want to allow to pass through, then we have to allow list. We need to add them here. So you see, these are the 2 interfaces that are a member of port channel. Port channel for vPC peer link. Oh no. Move to port channel to vPC. No, this is 20. No, that is correct. So I'll make it as 1. So this is for the peer link. This is over. Peer link is over. Peer link is ready. See, this peer link is ready. The peer link is ready, the Keepalive link is ready. What is left is the member port. This member port, let's say this is port channel 100. Here also we are going to have port channel 100. So how do? We go under the interface. And then we say channel group, you belong to 100. These are the member ports. Actually, in this example, they have taken 2 links. In our example, we just got only 1 link. In that example, they have taken 2 links from each switch. What are they? Ethernet 1/9 and 10. On switch 1, this is 9, this is 10. 10, 9. And then we say channel group 100. Then we go under the interface port channel 100 and we say this is VPC. This number doesn't matter, just an ID. This number doesn't matter, not necessary to match with this number, not really necessary, but mostly people will match like this. Even if you don't match, it is okay. Even if you don't mention this, if you simply say VPC, that is enough. You don't need to even mention this number, but people used to do that, matching with the domain ID, it is okay. And then this can be a trunk. This bundle can be a trunk or an access. In our example here, they are making it as an access. Port channel 100 will be carrying VLAN 101, which means 101 traffic that enters will be using this vPC. Yeah. So this is it.
Sir, one question here.
Yeah, please.
We are making this switch port access VLAN 101 for this port channel 100, okay?
Oh.
So only the VLAN 101 is passing through this link, right?
Yeah, no other VLAN, because it's an access. It's not a trunk port channel. It's simply an access port channel. But if you want it to be a trunk, you can say switch port mode trunk, switch port trunk allowed VLANs, and we can say what all VLAN. If you don't say, all VLANs will be allowed.
Okay, so in this case we are only allowing 101 only.
Yeah, only 101. Only 101. That's all. VPC is very simple. The verification command is show VPC. Straightforward command, show VPC. So when we say show VPC, it will show whether VPC is up or not, how many VLANs are allowed. If there is any conflict between these 2 switches in configuration, even those conflicts can be seen just by typing this command, show VPC. Let me try to get a output of this from Cisco side. So when we type show VPC, yes please.
Sir, can you hold a while? I will take some water to.
This is the main thing that I want to explain you about, though it is an optional one, when to use this. See, there is something called system priority. By default, it will be 32667. If you are changing it, if you are changing this, you need to change the same thing on both the devices. You see, ensure that you configure the same priority value on both VPC peer devices. We should change this priority on both the device. If the value does not match, the VPC won't come up. The system priority that you want to set, actually the system priority is like who first goes and talks with whom, something like that. But it's not that important. System priority, just make sure that you have the same priority on both the side. If you don't configure, it is going to be same on both the side. So this doesn't have that big significance. But the role priority has got something to do. smaller the number, high preference is given. Preference to what? Preference to become a primary VPC. See, even though VPC is combining two devices, one device, between these two devices there is a role priority. There is a role called primary role and secondary role. What is the job of the primary device? The primary device will take care of this BPDUs and BPDU responses. See, we are trying to combine these two switches as one switch. This two switch is going to be one switch. So when the BPDU comes, both switch cannot respond because it is one switch. Only one should talk. The other should be silent. If both talks, confusion. So only the device with the primary role can respond to BPDUs and ARPs. So you may configure any device with the command role 1. Now that device will become the primary. But again, I'm telling you, this is not a preemptive one. Meaning, if already a device is a primary, by changing this role on the secondary device is not going to make this as primary immediately. No, it's non-preemptive. So the VPC role also defines a set of action to be taken by primary, VPC secondary. So when the primary goes down, listen please, this is very important. I made this as, let's say, primary. By setting role priority 1, this is role priority maybe 1024, something like that. Some number. So it can be any number between 1265636. The default is this. But I'm saying here on one side 1 and another side 1024, thinking that this will become a primary. Yes, it will become a primary. This will be the secondary. So now this will be, the primary will be taking responsibility for all the BP, DU, sending and receiving plus ARP. Secondary won't respond. Fine, that's good. But what if this primary goes down? When the primary goes down, this becomes the primary. Though it is secondary, configured by you as secondary, this becomes primary. And now, when the primary that you configured comes up, when this comes back, this will continue as secondary. This is already now taken a role as primary now. When this original primary goes down, secondary has become primary. So when the original primary comes back, it cannot retain the primary position. It has to continue as a secondary. This is what I meant non-preemptive.
Yes.
Yeah. So the range of value is between this and this. The default is this. The lower value means the better chance of becoming primary. That's it. That's all about VPC configuration. So when we get chance on the command line, we'll do and see this. Let me show you some output. This is the mostly used show command on VPC. Show VPC or VPC brief. It shows that the domain ID, in our case, I think the domain ID we gave is 5, I think. So this will be 5. And this will say VPC the PF status should be okay. The Keepalive should be up. And then the configuration consistency means both the side. If the configuration is perfectly matching, then it will say successful. per VLAN consistency, meaning here also you have the same VLAN, there also you have the same. Then successful. Type 2 consistency means all the rest of the things like the priorities and so on, system priorities and so on. Next is the VPC role. This is a primary device. Number of VPC configured is only one. Peer gateway, this is for layer 3 anyway, this is not needed. Graceful check, not that. See, this is what peer link. In our case, I think I gave port channel 1, here also 1, allowed VLANs, and this is the VPC port channel. VPC port channel, VPC ID is 10 and successful. These are the VLANs that is active. And then this is a trunk VPC. Trunk, but in our output we were not using trunk, we were using for 101 VLAN. Where is this? Here it is. Somewhere down. Yeah, here it is. If you want to match with the output here, then it should be trunk. I should say switchboard trunk, switchboard mode trunk, switchboard trunk allowed VLAN 1 and 100. That's all, you know. So
this configuration which you are saying now, we are saying this is only in one switch, right? So this should be
identical on this.
Right?
Yeah, it should be identical. Otherwise, the consistency check will fail and VPC won't come up. If you see here, it needs to be identical. In everything, you know, it should be identical. Consistency, status, everything should be identical. Only then the VPC is going to be good. Otherwise, you will see like failed or something like that. You should not get any failed. Successful is what we need. So what I can do is just cut and paste. That is good.
No.
Yeah. All right. So the down switch is a normal LACP. Normal LACP or normal on mode. Nexus don't support PAGP. Normal ether channel configuration. There is no extra commands needed. According to the down switch, the above two switches are seen as single switch. So whatever you do in a normal port channel is what you need to do here.
Sir, one more question. What are the main advantages of doing by combining two switches into one? And right now we can only combine two switches, right? We cannot combine three switches.
No.
Okay, so what is the main advantage? Like if one
you don't have blocking port.
Like the primary.
You don't have
the main or
no. Both are going to be primary. This is primary. Sorry, both are going to actively forward the traffic, but this is the only one which will respond to ARP and BPD.
Okay.
Both are forwarding.
So other than this, what is the main advantages? Like
advantage is no blocking. See, if it is normal layer 2, when you have three switches like this, what happens? BPDU
there is blocking for STP.
will go and tell STP there is going to be a loop, so it will block here. So only this part of the resource will be used. This switch cannot be used. This bandwidth cannot be used. This bandwidth cannot be used. No switches on the right hand side can be used. Will be idle. So that's the big advantage.
Okay. But in per VLAN PVST we can load balance, right? This link.
Come again.
In per VLAN spanning tree.
No, that is manual load sharing. You need to manually do that by setting priority. This is dynamic. Yep.
Okay.
All right then. So